Hello, dear children. Today we are going to learn about the gravitational potential energy. We already studied in the last year the concept of potential energy. Potential energy is nothing but the stored form of energy in an object because of its position or because of its state. It is said to be the potential energy. Potential energy increases as we go above the earth surface. If we on the earth surface, then the potential energy is equal to 0. We already assumed that the potential energy of an object of mass m at a height h from the ground is nothing but the mgh. Dear children, h is small compared to the radius r of the earth. We can assume that g to be constant and we can use the formula mgh. For a large value of h means if the object is above with a greater height, then the value of g decreases with increase in h. For an object at infinite distance from the earth, the value of g is 0 and the earth's gravitational force does not act on the object. So, it is more appropriate to assume the value of potential energy to be 0 there. For smaller distances, the potential energy is less than 0. It means that the potential energy is negative. When an object is at a height h from the surface of the earth, its potential energy is minus gmm upon r plus h. Here, capital M and capital R are nothing but the Earth's mass and radius respectively. This is all about the gravitational potential energy. Now let's see the escape velocity. When a ball is thrown upwards, its velocity increases because of the gravitation of the earth. Velocity becomes 0 after reaching a certain height, and after that the stone starts falling down. Its maximum height depends on its initial velocity. According to the Newton's third equation of motion, that is, v square is equal to u square plus 2as. In this formula, v is equal to the final velocity, u is equal to the initial velocity of a ball, which is equal to 0, and a is equal to minus g. That's why 0 is equal to u square plus 2 minus g s, and maximum height of the ball, that is s is equal to u square upon 2g. Dear children, higher the initial velocity u, larger is the height reached by the ball. The reason behind this is that the higher the initial velocity, ball will oppose the gravity of the earth more, and larger will be the height to which it can reach. We have already studied that the value of g keeps decreasing as we go higher above the earth's surface. Force pulling the ball downward decreases as the ball goes up. If we keep increasing the initial velocity of the ball, it will reach larger and larger heights. And above a particular value of initial velocity of the ball is able to overcome the downward pull by the earth and can escape the earth forever and will not fall back on the earth. This velocity is called escape velocity. Dear children, object going vertically downwards. Dear children, object going vertically upwards from the surface of the earth having an initial velocity equal to the escape velocity escapes the gravitational force of the earth. The force of gravity being inversely proportional to the square of the distance becomes zero only at infinite distance from the earth. This means that for the object to be free from the gravity of the earth, it has to reach infinite distance from the earth. On the surface of the earth, kinetic energy is equal to half mv square and potential energy is equal to minus gmm upon r. Total energy is equal to E1 is equal to kinetic energy plus potential energy, that is half mv square minus gmm upon r. At infinite distance from the earth, kinetic energy is equal to 0, potential energy is equal to minus gmm upon infinity is equal to 0. Total energy is equal to kinetic energy plus potential energy. 0 plus 0, it will be 0. From the principle of the conservation of energy, E1 is equal to E2, that is half mv square minus gmm upon r is equal to 0. V square is equal to 2gm upon r and V is equal to under root of 2gm upon r, that is equal to under root of 2gr is nothing but the under root 2 into 9.8 and the value of r is 6.4 into 10 raised to 6, that is equal to 11.2 kilometer per second. The spacecrafts which are sent to the moon or other planets have to their initial velocity larger than the escape velocity so that they can overcome Earth's gravitational attraction and can travel to these orbits. Thank you very much.